The purpose of this video is to introduce the law of sines. Um, and what you do with the law of sines, unlike law of cosines where you need to know at least two sides, here on law of sines, you can solve problems where you have two angles. For example, as we see on triangle forms, they could be angle side angle, as we have right here, or angle angle side. And then we'll also introduce a case called the ambiguous case called side-side angle, where you know two sides and an angle in that order. The formula, which we're going to be using, is the following. Now it looks confusing because we have three sets of these fractions or ratios, but we'll be utilizing two sets. And what we're doing, if you look on the triangles, we have triangle ABC right here, is that for every side in relationship to the sine of its angle, they are equivalent. So larger angles will be across from a larger number, so the ratios are going to be the same. So we'll be utilizing this formula, but how we utilize it, it will be with just two ratios as we see our different forms. So we'll look at three different examples today where we're going to be solving for either a missing side or a missing angle. Example 1. In this case right here, notice this is a angle side case that we're going to be utilizing. So in doing this, notice that we have angle A is equal to 40 degrees, angle C is equal to 60 degrees, and side B is equal to 12. Now what this immediately allows us to do is to find the missing angle B, because if we have two angles of a triangle, we can always find the third. So since A is 40 and C is 60, that's 100. This is going to be 80, so we'll go ahead and fill that in. Now here's how we utilize the law of sines. We'd be unable to use the law of cosines because you have to know at least two sides to use law of cosines. So our first ratio is going to be the following. Now remember, we had the general form for law of cosines is A over sine of angle A is equal to side B over sine of angle B is equal to C over sine of angle C. Now what we're going to look to find in this particular case is side A. We want to find side A. Okay, so A is right here. Now the way that we set up the ratios is the following. We don't use all three of the ratios, we'll just use two of them. So if we want to find side A, we'll take A divided by sine of angle A. We'll fill in the value for the angle in a moment. And then we also know, and you do have to know one angle and the side across from it to be able to use this process. So it'll be side B over sine of angle B. So we'll fill in our information. Side A we do not know, but sine of angle A is sine of 40 degrees. So make sure that we're dealing with, when we use our calculators, we're in degree mode. Then we know side B is 12, so we'll fill in for side B 12, and sine of angle B will be sine of 40 degrees. Now, 80 degrees. Now, in order to solve for this, we will be able to cross multiply. So, in cross multiplying, we will take A times sine of 80 degrees, and it'll look like the following. And that will be equal to 12 times sine of 40. Whoops, sine of 40, I'll just write it this way. Sine of 40 times 12. Put parentheses around the 12. All right, now to solve for A, remember sine of 80, we don't want to take sine of 80 because we'll be rounding and introducing error, but we will divide both sides by sine of 80. So that divides out, and then our answer for A will be sine of 40 times 12 divided by sine of 80. We'll round this to the nearest tenth. And this is equal to, and you can check this on your own as well, approximately 7.8, rounded to the nearest tenth. Now what that's saying is if we look up here, this value is approximately 7.8 we have found. Once we've done this, then we could find the missing side over here, which would be side C, by using law of cosines, because we know a side, an angle, and a side. So notice it's across from a smaller angle, 40 degrees, than this side B, 12, which is equal to 12, is across from 80. So it makes sense that it would be less than 12. As we move on to example 2, this case, we know two angles again, but this is angle, angle, side. So we know angle A, angle C, they are right next to each other, and side A. So we set up our formula to solve this. We'll take two parts of the law of sines. We will take, and we want to, in this case, we're going to look to find side C. So we're going to find C. So we will take side A divided by sine of angle A is equal to side C, which is the one thing we don't know, divided by sine of angle C. So we'll fill in our information. A is 10. Sine of A is sine of 50 degrees. And that will be equal to side C, which we don't know, and sine of angle C, which is sine of 85. Cross multiplying again, this will give us 10 times sine of 85 degrees. 10 times sine of 85 is equal to C times sine of 50. Solving is the same as the previous example. We'll divide both sides by sine of 50, which remember is just a number. So C will be equal to 10 times sine of 85 divided by sine of 50, which rounded to the nearest tenth is 13. So if we look at this side C, this is equal to about 13. I'll just put 13 there. And it makes sense because across from angle 50, we had a length of 10. A larger angle, we have to have a larger length. Now before we get to example 3, it deals with what's called the ambiguous case. And we just want to introduce this today. Ambiguous case, essentially, if you know, and this is if you know two sides and included angle, there can be 1, 2, but then there also could be 0 triangles that would fit this criteria. And the way that we can show this is that it depends on, so you're going to know angle A, side A, so you're going to know one angle on the side across from it, and then another side. In the first case, case number 1, A is less than H. What we mean by H is this would be a perpendicular from this point, which would actually be angle B. And notice this is not a real triangle. And this length right here, if this side A is less than this length of H, then you have no triangle. Well, if we look at the right triangle made by this side H, this is sine of angle A is equal to the opposite over the hypotenuse, which is H over C. So C times sine of A is equal to this H if we multiply both sides by C. So if that value of H turns out to be larger than A, this would be 0 triangles. If we go on to case number 2, if A turns out to be the same as this length H, notice this is a special triangle right here, so if they turn out to be the same, that's a right triangle. So you'll end up with just one. The next case, as we scroll down, is if this length of A, and this is the key ambiguous case, if this length of A turns out to be between the length of H and C, because if we look at, if I were to drop a perpendicular here, if this is H, A is larger. So what that means is you can make two triangles, and I'll try to show the other example. So this is going to be an example of two triangles. And the other triangle would look like this with the same bits of information. You would have this side, you'd still have angle A, and this angle has to be the same. That should be a straight line. But now this side A could move in more toward the angle. Okay, we'll have to pretend I can draw a triangle. But we have angle A, and we have side A, which is the same length as this one over here, side C, which is the same length, use your imagination, and then notice that our angle, this would be angle B, is completely different. So even though we have 3 bits of information that have not changed, we've been able to move that side. And then the last case is where this length of C is just less than your side A, and this will only be one triangle. There's no other triangle you can make, less than or equal to. So those are our 4 cases. So our last example will deal with this case. Now we won't deal with the part where we could have 2 triangles, but we'll take a case, and this is actually the case number 4. So what we have on this one is that we know angle A, side A, and then this side C. So notice we have side, side, angle. So we'll take side A over sine of angle A is equal to side C, which we will know, over sine of angle C. So we're going to find this angle C. Now this is the angle we're finding. So we'll put in our information. A is 7. Sine of A is sine of 30 degrees. C is 6. And we do not know angle C. So when we cross multiply this time, I'll write it over here. When we cross multiply, we will end up with 7 times this sine of C is equal to 6 times sine of 30. Now this is a special case in that 6 times sine of 30 is 1/2 or 0.5, so I'm just going to write 3. We'll divide by 7 because we need to isolate sine of C, so we'll divide by 7. And so sine of this angle C is equal to 3/7. So remember, if we want to find the angle, that's where we use the inverse. Inverse sine of 3/7. Okay, still in degree mode. This would turn out to be, I'll just write it over here, C is equal to 25.4 degrees. So these are a few examples that deal with, deal with our new topic of law of sines.